Good morning. In my previous lecture, we have discussed about the matrix method and DFT as a linear transformation. Remember? So today we'll start with the properties. I've already told previously in my last lecture that then in today's lecture, the properties of discrete Fourier transform will be explained. So, what can be the properties of a discrete Fourier transform? Obviously, the properties will have the same usual names, like periodicity, linearity, symmetry, time reversal, circular time shift, like this. So, let me share the screen. I'll be showing you, and thereby you'll be finding out the properties of discrete Fourier transform. Clear? Okay, so here we are. So what are the properties of discrete Fourier transform? You see, first of all, before knowing the properties of discrete Fourier transform, we should know the notations, the way to write a DFT and inverse DFT together. Together, if you want to represent a DFT, that is a discrete Fourier transform, as well as inverse discrete Fourier transform, then how will it be? How? See, the following notation is used to denote the n-point DFT pair xn and xk. So what is xn? Xn is just a signal whose DFT is found out, and we get xk. Similarly, we get xn by doing IDFT of xk. So xn DFT, you get xk. Again, xk IDFT for n samples, capital N samples, you get xn. It's just a reversible line written like this. Now, about the periodicity property, a function, a function is periodic, fx, it's periodic at period t if f of x plus t equal to f of x, isn't it? Similarly, if xn and xk are related by DFT in this manner, then x of small n plus capital N will be equal to x of n, means small n. Again, x of k plus capital N will be equal to x of k. Now, what are the range of these statements? This statement, x of n plus capital N equal to x of n, it's for all values of n. Again, x of k plus n equal to x of k, it's for all values of k. Okay. Next property. I'm not going to the details because we don't have actually things related to the properties, only you have to know. I don't give you all the properties. I just give you some properties that you will be requiring for doing problems on DFT. Yeah. So about linearity property, if x1n gives you x1k through DFT and x2n gives you x2k through DFT, then ax1n plus bx2n through DFT will be giving you ax1k plus bx2k. This is our linearity property. Now, what is A and B? A and B are nothing but constants. A and B are nothing but constants. Clear? Okay. So the third property is the very most important property about circular symmetry. So what is circular symmetry? What is symmetry? First of all, you have heard the symmetry property of twiddle factor. 1 or 2 days earlier, I had already told. So what is symmetry? And after that, what is circular symmetry? Symmetry means a patch. you can say symmetry is a proper sequence of explaining something or of denoting something. Clear? Now, circular symmetry means you suppose a clock and you are pointing 4 points inside the clock. Suppose at 12, at 3, at 6, and at 9. So all the 4 points are equidistant from each other. Clear? Just imagine, just visualize a clock. Points, there are 4 points, 4 digits that are written over there. One is 12, one is 3, one is 6, one is 9. Now, shifting will be done on the basis of symmetry and on the basis of requirement. Shifting will be done on the basis of symmetry and on the basis of requirement. So endpoint DFT of finite sequence xn, endpoint DFT of finite sequence xn of length L, capital L, which should be less than or equal to the number of samples, is equivalent to endpoint DFT of periodic frequency EXPN of period n. Clear? I begin repeating. Endpoint DFT of finite sequence xn of length L, which should be less than or equal to capital L, is equivalent to endpoint DFT of periodic frequency EXPN of period n. Now going to the next page. I need to zoom it a bit so it will be easy for you. So EXPN, you see, EXPN is denoted like this: summation L equal to minus of infinity to infinity x of n minus L into capital N. Okay, so where capital N is the number of samples. Now, my question is, if we shift the periodic sequence EXPN by k units, suppose we are shifting the periodic sequence EXPN by k units, okay, to the right. So it will be xp dash n, if we denote, then it will be equal to xp of n minus k, to the right, n minus k. So it will be the summation of L equal to minus infinity to infinity x of n minus k minus ln. This will be the difference in the two formulas. Okay. Now, the finite duration sequence x dash n will be equal to xp dash n if n lies between 0 and n minus 1, and will be equal to 0 at any other points of it, or at any other values of it, rather, is related to xn, means this x dash n is related to xn by circular shift. X dash n is related to xn by circular shift. In general, circular shift is represented by the, it is called, remember the term, it's a very important one. I'll be giving the note, no need to worry. In general, circular shift is represented by the index modulo capital. Okay, so what is this index modulo capital? I'll explain. So thus we get x dash n will be equal to x of n minus k comma modulo n, and this x of n minus k comma modulo n is denoted like this: x of n minus k, again you put a first bracket in the suffix, you write plus n on the right side. That means x of n minus k modulo n. Clear? Now, if k equal to 2 and n equal to 4, obviously x dash n will be x of n minus 2 modulo 4. Clear? So likewise, x dash n, if it is x of n minus 2 modulo 4, then for k equal to 2 and n equal to 4, x dash 0 will be equal to x of 0 minus 2. Imagine n equal to 0. 0 minus 2 modulo 4. That means x of minus 2 modulo 4, which will be equal to x of 2. Okay. X of 0 minus 2 modulo 4, which will be equal to x of 2. Now, how this x of minus 2 modulo 4 is becoming x2? You understand one term, you will get the other terms. Like x of minus 1 to the modulo 4 is x3, 0 modulo 4 is x0. How? How you are getting this? You see, x dash 0. X dash 0 means from 0, the shifting is occurring. The circular shift is occurring. By how many units? Here k equal to 2 and minus 2 means shifting to the right. So it will be x of 2. X dash 1, it will be x of 3. X dash 2 will be x of 0. Similarly, x dash 3 will be x of 1. Here, again I am telling you, k is the times how much it is shifting, and here minus 2, if it is plus 2, shifting to the left, minus 2, shifting to the right. Then minus 2 means here is minus 2 modulo 4, so x of 2, x of 3, x of 0, x of 1. Here. So in short, you see, I've written the general formula. X of n minus m modulo n equal to x of n minus m plus n. Remember this, you'll get any answer. X of n minus m modulo n equal to x of n minus m plus n. Okay? Clear? Now, in the next slide, we'll be showing you the circular convolution and multiplication of two DFTs. Now, first of all, what is circular convolution? What is its difference with linear convolution? See, circular convolution occurs between two signals, one which is finite and the other one, it may be finite, it may be infinite. Okay. Circular, again I am telling you, circular convolution occurs between two sequences, one which is of a finite length and the other can be a finite one, can be an infinite one also. Clear? So, since circular, so this is the cause. Now, if it is linear, then it's confirmed that the two signals or the two sequences will be obviously a finite length sequence of finite duration. Clear? So, since it is circular, so I can confirm that one can be either finite or infinite and the other will be finite. That's confirmed. So, if I find the circular convolution of two sequences, so this is the, actually this is the formula for circular convolution. The n is written inside a circle, circular convolution. This denotes circular convolution. x1n, circular convolution of x2n gives you x1k, x2. So now go to a formula, go to a problem. You'll be understanding better. You see, find the circular convolution of two sequences. One is x1n equal to 2, 1, 2, 1. x2n, it's 1, 2, 3, 4. Okay. So here there are 4 samples in both the sequences. You are having 4 samples in both the sequences. Now, using DFT and IDFT formulas, we have to find the circular convolution of the two sequences. Clear? Now, this problem I have done by Stockham's method. It is done by Stockham's method. I repeat, Stockham's method. Now, you see, what is x1? 2, 1, 2, 1. So, what will be x1k? If x1n is this, then x1k will be DFT of this. So, it is summation of n equal to 0 to n minus 1 xn into e to the power minus j 2 pi kn by capital N. Here, n minus 1 is 3. So, number of samples n is 4. And k will be 0, 1 up to n minus 1. So, what is the third point of k? It will be 2 and the last point will be 3. So, we will be calculating x1 for 4 values of k. Similarly, we will be calculating x2 for 4 values of k. Likewise, it will go on. So, at k equal to 0, x1 0. Obviously, x1 k. So, x1 0, it will be this. This is the general formula. Now, in each term, we will be putting k as 0, 1, 2, then 3. And you will be getting these values, 2 plus 1 plus 2 plus 1, it will be 6. At k equal to 1, x1 of 1 will be 0. At k equal to 2, x1 of 2, you are getting 2 minus 1 plus 2 minus 1, which is 2. At k equal to 3, x1 3, you are getting 2 plus j minus 2 minus j, which is 0. That means x1 0 or x1 k, you have got 6 0 2 0. This is the set for x1 k. Now, in the step 2, it's a big problem, but very easy. Just understand and get it simplified. It will be very easy. So, x2n it's given in the question, you see, 1, 2, 3, 4, isn't it? So, if x2n is 1, 2, 3, 4, here n minus 1 equal to 3, and so n equal to 4, and k equal to 0, 1, 2, 3. So, x2k equal to summation of n equal to 0 to 3 x2n into e to the power minus j 2 pi kn by capital N, middle factor. Okay. So, again, for k 4 terms, 0, 1, 2, 3. So, at k equal to 0, x2 0, you have to find out. You see, at k equal to 0, x2 0. 1 plus 2 plus 3 plus 4, you get 10. For k equal to 1, x2 1, it's minus 2 plus j2. For k equal to 2, x2 2 equal to 1 minus 2 plus 3 minus 4 gives you minus 2. For k equal to 3, x2 of 3 equal to 1 plus j2 minus 3 minus j4, which gives you 2 minus j2, minus 2 minus j2, pardon, minus 2 minus j2. So, therefore, x2 of k gives you, the solution set for x2 of k is 10 minus 2 plus j2 minus 2 minus 2 minus j2. Clear? Now go to step 3. Obviously, step 3 will be, you have got x1k, you have got x2k. Now your third step will be to multiply, because convolution, obviously. So convolution means multiplying two DFTs. So multiply and denote it as x3k. So x3k equal to x1k into x2k. So x30 equal to x10 into x20 equal to 60. x31 equal to x11 into x21 equal to 0. x32 equal to x12 into x22 equal to 0. And x33 equal to x13 into x23, which is equal to, again, 0. Okay. So x3k gives you 60, 0, minus 4, 0. Clear? Now go to step 4, the final step of the problem. You'll be getting the answer over here. So this x3k, you'll be finding the inverse DFT of x3k. So x3k's inverse DFT will give you x3n, and that will be equal to 1 by n summation of k equal to 0 to 3 x3k e to the power j 2 pi kn by 4 because n equal to. So likewise you have given put the formula, and now at n equal to 0, x30 will be 1/4 of 60 plus 0 minus 4 plus 0, which gives you 14. At n equal to 1, x31 equal to 1/4 of 60 minus 4 into minus 1 plus 0, which gives you 16. At n equal to 2, x32 equal to 14. At n equal to 3, x33 equal to 16. So the final answer by doing inverse DFT of the two DFTs of the two sequences, you've got x3n equal to 14, 16, 14, 16. Clear? This is all about circular convolution and Stockham's method. Again, we will be finding the circular convolution of two sequences. You see, x1n, it's given 1, 2, 2, 1. It's a different problem. And x2n is equal to 2, 1, 1, 2. Clear? Now here, we won't use the Stockham's method. We will be using a simpler method than that. What simpler method? We will be using circular shift. Clear? Circular shift. So, since circular shift we will be using, you see, x3n equal to summation of m equal to 0 to n minus 1, summation of m equal to 0 to n minus 1, x1m into x2 of n minus m modulo capital N. Now what is capital N? Capital N is 4. So now x30. First we have to calculate x30, obviously. So then we will be calculating x31, then x32, then x33. So first we will be calculating x30. So x30 means small n equal to 0. So it will be, formula will be summation of m equal to 0 to 3, x1m, x2 minus n modulo 4. So x30 equal to x10 into x2 of 0 modulo 4 plus x11 into x2 of minus 1 modulo 4 plus x12 into x2 of minus 2 modulo 4 plus x13 into x2 of minus 3 modulo 4. Clear up to this much? Now in the next line, x30 will be equal to x10 as it is, it will be remaining, and x20 modulo 4, obviously it is x20. Circular shift, remember? Again, x11 plus x11 into x2 minus 1 modulo 4 will be x23. x12, x2 minus 2 modulo 4 will be x2 of 2, and x13, x2 minus 3 modulo 4 will be x2 of 1. Circular shift. Clear? So x3 of 0 gives you 1 into 2 plus 2 into 2 plus 2 into 1 plus 1 into 1, which is 9. Similarly, x3 of 1 gives you 1 into 1 plus 2 into 2 plus 2 into 2 plus 1 into 1, which is 10. x3 of 2 gives you 1 into 1 plus 2 into 1 plus 2 into 2 plus 1 into 2, which is 9. x3 of 3 gives you 1 into 2 plus 2 into 1 plus 2 into 1 plus 1 into 2, which is 8. So final answer of x3n is 9, 10, 9, 8. Clear? So this is a shorter method. You can do it using circular shift. It's very easy. And I think if you don't feel it comfortable, then the best method to solve without any problem, without any hesitation, is the Stockham's method. It is a bit longer, it's a bit lengthier method, but it will be easier for you. Clear? Now, we'll be moving to other methods for finding circular convolution. Circular convolution can also be found out using graphical method. Circular convolution can also be found out using concentric circle method and using matrix method. So in your syllabus, there is matrix method. So I'll be explaining a problem using matrix method so that it will be clear for you. And it's the most easiest one, I hope, for you. You see, question is given. Find the circular convolution of two finite sequences using matrix method. x1n, 1, minus 1, minus 2, 3, minus 1. And x2n is 1, 2, 3. So our first work over here will be equating the lengths of the two sequences. Yeah, you see, x1n and x2n are of different lengths. I've written that two sequences are of different lengths. So how will you equate the length? How will you? You cannot decrease the length of x1n, isn't it? Can you decrease the length of x1n? They are having certain values. No, you cannot decrease. So what you have to do to equal the lengths of two sequences, you have to increase the length of x2n. Clear? You have to increase the length of x2n. And how will you do it? We will be doing it using our concept that we all know, zero padding. So already studied earlier. I've already taught you what is zero padding. It's nothing but adding simply zeros to the end of a sequence for lengthening it. So here the zero padding concept will work. You'll be using zero padding concept. So here zero padding is done with x2n. And after doing zero padding, you see x2n 1, 2, 3, 0, 0. Clear? So now both the sequences are having 5 samples, n equal to 5 with n equal to 5. So you have to compute the circular convolution. So how will you do it? You see, circular convolution means first you have to compute the x2 matrix, x2n matrix. This is your x2n matrix. This is your x2n matrix. So how to write the x2n matrix? You see, in the first column, you will be writing it like this: 0, 1, 2, 3, 4. Clear? In the second column, the value of the last element in the first column will be coming up. So 4, then it will follow 0, 1, 2, 3. Again, in the third column, 3, then 4, then 0, then 1, then 2. Again, 2, then 3, 4, 0, 1, then 1, then 2, 3, 4, 0. It's very simple. Clear? Equal to x2n. What will be x1n? Obviously x1 0, x1 1, x1 2, x1 3, x1 4. Column matrix. It's just a column matrix. Clear? And what is x3n? The output, the product, or the value that we'll be getting, that is your output, x3n. So x3n will be what? x30, x31, x32, x33, x34. This is also a column matrix. Clear? So our x1n and x3n are column matrices, and x2n will be both row column matrix, and it will be of equal order. Means it is of a 5 cross 5 matrix over here. Okay, since why 5 cross 5? Because n equal to 5. So number of samples will be indicating the order of matrix. If n equal to 4, then x2n will be a 4 cross 4 matrix. x1n will be a what? 4 cross 1. x3n will be a 4 cross 1. Clear? Now just replace the values. You see, x2 0, x2 1. I'm considering the first column. x2 0, x2 1, x2 2, x2 3, x2 4. So x2 0 is what? x2 0 value is 1, x2 1 is 2, x2 2 is 3, x2 3 is 4, x2 4 is also 4. You see, 1, 2, 3, 0, 0. Now, if you don't see the other values also, if you don't see according to the formula also, you can just rotate circular way. You can just put this single 0 at the top, then 1, 2, 3, 0. Again, this 0 at the top, then 0, 1, 2, 3. Again, 3 at the top, 0, 0, 1, 2. Again, 2 at the top, 3, 0, 0, 1. Clear? Now, x1n. What is x1n? It's a column matrix symbol, 1, minus 1, minus 2, 3, minus 1. So it is here 1, minus 1, minus 2, 3, minus 1. Now you will do simple matrix multiplication, and the resulting value will be getting a 5 plus 1 column matrix. It will be 8, minus 2, minus 1, minus 4, minus 1. Clear? So our final answer, the x3n is 8, minus 2, minus 1, minus 4. So this is a value of circular convolution of two sequences using zero padding, as one of the sequences having unequal length. We'll be increasing the zeros. We have increased the zeros in fact. We have equated the number of samples to 5. Initially, one sequence was having sample 3, one was having sample 5. So the sequence which was having sample 3, we have increased it to sample 5, and then we have dropped it. Okay, so that's all for today. Thank you.